record. Today we are, of course, going to talk more about Inventor. So we talked a whole lot about how to do different two-dimensional drawings or sketches. So today we're going to talk more about what happens when we go to 3 dimensions. So let's create another drawing, another part. For now, we're going to be sticking with parts. And so, as we said, we talked a whole lot about all these different parts and sketches and constraints and how to modify and the pattern and all those kind of things. And now we want to explore a little bit more what we see here in the 3D model part. But of course, to do that, we have to start with a two-dimensional sketch. So let's just do rectangle, I don't know, 10 by 20. Oops, that's not what I was looking for. Hit the wrong button. There we go. And 20. All right, nothing fancy. And then we already learned, right, that we can use the extrude tool to make this go from 2 dimensions to 3 dimensions. I just want to go through this extrude tool with like a little more detail. So this is the first thing that we create, right? So it automatically just gives us that it's going to add, or it's create this new solid that's going to call solid 1. Call it anything you want, right? But that's what it does. Up here, you can see it will ask you where the profile is, like what profile to choose. Now, in this case, there's only one, so it automatically has it. And then this will go on this one a little bit more once we have an existing object. But some of the other important ones are up here, right? So this tells in what direction it should be extruded. So this will be going in its positive direction, whatever it defines positive to be, in this case up, right? If I click the one that goes in the negative direction, that'd be going down, half up, half down, or I can give it how much up and how much down, right? So those are these things that we can use. This is the kind of the standard. And I think for now, we'll just create our one big block right there, right? That's what you already did. Now, until now, we've only basically extruded in one direction and then we're done. Like maybe we've extruded in one direction and did another sketch and cut into that direction, right? But we haven't done anything more specific than that. But what we can see now is that any of these surfaces that we can see, or even the ones that we can see, right? If we flip this around, right? Any of these surfaces I can create a new drawing on and then continue extruding, right? So I can create very complex 3-dimensional objects just by starting on one surface and going to the next. By the way, I don't see any cameras on this morning. Everybody just woke up and still in.
Dr. Carl, I'm here, but I still have the camera issue.
Okay. We'll have to work on that camera issue. All right, very good. I have a couple cameras. That's fine. So we can draw on any of these, right? So we could go and we could say do another sketch, and then it creates this little icon, right? And then we can choose whichever we want to. But there's an easier way. We can just go to whatever surface you want to draw on and hit the right mouse button, and then we get all these different options. And one of them is the new sketch. And so we hit that, then now we can draw on this side. All right, so maybe we want to draw another rectangle. Draw another rectangle, and now we can extrude again, right? So now you'll see we get a couple more options, right? We get different options here for the output, and also we get for the distance, we also get different options. Let's maybe start with the output. So the first one here is basically says it is going to add, right? So in Inventor, anything that you add to this one solid body becomes that solid body, right? So this is not something new, right? So this would be, in this case, it would be adding this shape by joining it, right? So we'd have the big block and the little sticking out on top. We can also do a cut, right? And it automatically decides if you want to cut, it's going to go down, because if I do the cut upward, there's nothing to cut, right? So basically what that does, it takes that shape and and deletes whatever was there beforehand. Then we can do the intersect, which is not very common to do, but that will be kind of, it takes only the stuff that's in both, right? If I do it on the top, then there's nothing, right? Because there was nothing there before. And then the last one, which we're not going to use, at least I usually don't use it very much, is to create a brand new solid, right? So we had our solid one, this is this big block, and then we could have a second solid, right? So now if we wanted to do different materials or something like that, right, then that'd be useful. But for us, usually what we do is either the adding to it or cutting into it. So let's do a cut. So we'll cut down. And then of course we can decide how far we want to cut, right? So this case cuts all the way through because it was 10 millimeters. If we just cut 5 millimeters, kind of cuts a hole. And then we have some options here, right? So this one basically says the exact distance or like how far we want to cut this, right? So we could say we want to cut it all the way to the surface down here. Oh, we'll cut it all the way through, right? That would be one option. We can say how far we want to cut it. So we have many, many different options that we can use there for cutting. But in this case, let's go cut all the way through, right? So then if we look from the top, we can see that we cut a hole into our system. Right, so of course we can keep on going and going and going. Maybe we'll draw on this side next. Move that into the center. Let's now do another rectangle to show you one more special option here for the extrude part. Let's do finish and then do extrude. Right now it chooses again that it sees that it has that one. And now what I want to do, I'm just going to extrude it out for 10 millimeters is fine. But then you see here that I have what is called a taper, which basically means that instead of I can only go straight up from my surface, but I can say that I can indent my sides, right? So if I want to do a taper, if I click on this, then you can see I get a nice little arrow here, and that kind of makes a little pyramid, or I can do it the other way around as well, right? So there's all kinds of stuff we can do. I don't have to do it by hand, right? I can do it up here too if I wanted to have whatever, minus 15 maybe, and there we go, right? We just created a new part. Again, if we look at our solid bodies, right, we still only have that one solid body because we created that on there. Now, if we wanted to create a new solid body, again, just for completeness, right, I can draw on this surface as well, right? It's just a sloped surface, so that's fine. I can do that. Becomes a little bit tricky just from a visualization standpoint, because now you'll see that it automatically has everything flipped because it turned everything now to have this one flat. But let's maybe do a little post on here and extrude that as well. Maybe not quite so high. All right, and so we'd have that sticking out. Now, again, if we wanted to create this as a new body, right, we can try to do that one, say solid 2, but let's just put it on there. All right, and what you can see, what's very important is that this extrusion happens vertical away from the surface, right? In math, you talked about normal directions, right, off of a surface. So this would be, it always goes in the normal direction. All right, so that would be kind of our big chunks here, right? That was a lot of stuff that we saw in the extrude. We're going to talk about the revolve a little later, and then some of these others we're going to talk about on Thursday. But maybe we will go through some of the other ones, but maybe we'll do this one real quick here because it's kind of a fun one. So this allows me to kind of either punch words into the system or kind of raise them out. To do that, I have to do another sketch. And so that was something that we didn't do is text, but we'll just put some text right there. You can see you can do all kinds of stuff here in your text, right? You can change all kinds of stuff. Looks like a good size. We'll say we'll finish, and then we can go to emboss. We'll choose that profile right there. And then maybe we'll cut it into it. And we say, well, 1 millimeter right there, right? So it cuts it into our face here. Kind of fun to play around with, I guess. All right, but some more important ones. We already know the concept of a fillet, right? We had that in 2D, but we can do that in 3D as well. And there's a whole bunch of different options, but like the standard option of just rounding off the one, right? We choose what our size is going to be, and then we choose our edge, right, that we want to put the fillet on. And if they connect each other, then it becomes more complex. Right, so we can do all kinds of stuff here if we wanted to. If we're done, again, of course, we can change what the size is, but if we're done, you can say okay, and there it goes. And you can see it does the relatively complex calculation of like kind of cutting into this shape, right? Because now if we look from this side, right, we can see, tinge it in just a little bit, right? We can kind of see that it had to cut into that part there. All right, that was the fillet. We can also do a chamfer, right? That was kind of the same idea as the fillet, but with a straight edge. I'll let you play that with your on your own time. But another important thing that we have is the hole, and so the hole basically allows us to, like until now, right, when we wanted to create a hole, we said we draw a circle and then we extrude in. That works perfectly fine if we just want to have a simple hole, but if we want to have something more complex, then this hole command is really good, right? So we'll just choose a random location here, and then we have all kinds of options. The main one that we're going to use is just going to be the simple hole, right? It's going to go through. But if you look at these other ones, you can see that this is where all the stuff that we learned about threads and fasteners comes in, right? So this one would be a unified, but we do a metric one, right? We can choose whatever we want to have. 5 is a little big here, right? We can choose something. No, we can't choose. All right, so and we can do these other ones too, but again, we'll stick mainly to the usual hole. Not sure why it's not going there. Well, let's restart now. So we just have a regular hole right there. And then we have a bunch of options here for what's called the seat, right? How do I want to have this hole? If I just want to have a regular hole, right there, right? No, nothing fancy about it. I can tell how far it's going to go, right? I can say it's supposed to go a certain distance. If I give it a certain distance, you can see that I can decide what the end of the hole looks like. Is it kind of the rounded or kind of the pointy piece, which means that it's kind of, we kind of take the drill into account, or just a flat one. I can tell it to go all the way through, which is kind of the standard, or I can say to go to a certain different surface, right? But usually we either say all the way through or a certain distance. You can also see that whenever I do something, that it changes my little sketch down here, right? It has all kinds of information in here. So now it says all the way through means 8 millimeters, or to go down 8 millimeter depth, and then it tells that I can change all these numbers down here as well to other things if I want to. But let's go back to all the way through. But so this will be a standard regular hole, but I can also choose one with a counter bore, right? So that was one of the options that we saw. The regular counter bore. Then here's one that's basically the same, has a slightly different name. And then also we can have the countersink where it was at an angle, right? And for each of those, again, we can change what size we want to have, right? Go back to my countersink here. Maybe I want to have it that it goes in a little farther. Maybe we'll say 3.5 millimeters, and maybe I want this to be bigger, and I'll choose 5 millimeters, right? And so then if I hit OK, then I have my hole built in there. I'd like to see where it is. If I flip this over, I can see at the bottom it only has the regular small hole coming in, right? So this will be the hole command, which is a pretty useful command to use if you want to have something that's more elaborate than just like a regular hole. Otherwise, I usually just draw a circle and do the extrude part. All right. chamfer, I already said that, you know, you kind of play with it on your own time. But another really cool one is the shell command. And it basically what it does, it takes your solid and it hollows it out. Now this shell command is very cool. I use it every now and then. It's not that common. If you have a shape that is very complex, then sometimes this tool is not going to work. But for what we have here, it should. So again, basically what it does, it takes this solid and it hollows it out. So if we do the shell command, then we have to decide which face it is that we want to remove so we can look in. So maybe we'll just remove this one right here, or let's flip it over. Let's do the side one here and should look a little better. Let's stick with this one because this takes away too much. So let's remove that side. And then how thick 1 millimeter is going to be way too big because our system is small. So let's do 0.1 millimeter. And then we hit OK. And then you can see that it basically hollowed out the entire system and left behind little pieces that are again, in our case, 0.1 millimeters thick, 0.1 millimeters thick, right? So, and you can see that even the letters that we embossed into here, right? It even hollows around them. So you can see all very well hollowed out. If you want to hollow something out and then and have a hole go through it, be careful that you do the holes later, because otherwise it's going to hollow around those holes as well. Right? So as you can see here, it leaves those out there. So that is the shell command. The draft command I don't really use very much. Basically, it allows you to kind of take a shape and pull it out. It's not that useful to me. But another one that's kind of nice, and for that one we'll create a new part here. So we don't get ourselves blocked up. So let's do another drawing. Let's do a cylinder, let's say 10 millimeters, and then we'll extrude it. Let's do this longer. Let's do 30. Right, so we have this peg basically, and now we said if we want to have a thread, right, we could draw this by ourselves. We could use these simplified versions, but Inventor allows us a third option, and that is it has its own thread command. Right, so I have to choose a circular surface just like this, and then it will try to fit a thread onto it. Now I chose a diameter of 10 millimeters, so it's automatically goes into metric profiles, and now all we can do is basically change between like a coarse and a fine, and you can see that we can do left or right-handed, all that kind of stuff, but goes over the entire thing. Right, so basically it makes this look like it has a thread on it. It's very important though to realize that it only makes it look that way. It doesn't actually cut a thread into this, right? So if I go up on here and do a new sketch and just put a rectangle on here to cut half of it away, right? So if I do extrude and then do the cut and say okay, and then I look from the other side, right? If this were a real thread, right, then I should be able to see kind of the zigzag as it goes around. But really all it is that kind of it creates the surface texture that makes it look like it. But if you have something where you have like what's supposed to be a thread, then it's relatively easy to do and makes it look really nice. All right, any questions so far? All right, then so like these are like smaller pieces. Again, like I suggest you go through and look at them, but we'll skip over to the patterns, and then we'll go back to the revolve. And again, on Thursday, we're going to talk about some of the other ones. But let's create a new part. And let's do another sketch, get us started. Let's do this one, maybe 40. by 20. Say okay, and then we'll extrude it. Not very far, maybe 2. And here we are. All right, so we have kind of this simple flat surface. And now let's say you want to put a whole bunch of holes into the surface. Right, if we wanted to do that, we can use our hole command, for instance. Let's do a regular hole, nothing fancy. Let's stick it somewhere right there. Make it a little bigger. 5. That was good. And we say, okay, all right, we can, if we look at it from top, we can say it went right through. Now, if we wanted to have a whole bunch of holes in all directions, right, we can keep on doing that. We can just create another hole, another hole, another hole. But just like we did with the simple, with the two-dimensional ones, right, we have these patterns that we can use. So again, we can choose a pattern here, and now instead of doing something two-dimensional, we have to grab something three-dimensional. You kind of hover around, you can see that this hole here actually counts as a feature, right? So we can choose that. For some reason, it's very finicky. There we go. So we chose the feature that we want to have, and then just like before, we have to choose directions. Now in 3D, it's a little easier because we already have edges, right? So we can say like we want to have one direction going this way, pointing the wrong direction, so flip it around. Maybe we want to have 4 of them. Yep, perfectly fits in there. Then if we wanted to have them the other direction, of course, we can do that as well. In this case, 2 that's in there. And we can say, okay, and we have our holes in there, right? Which is really helpful for us to do. Right, so that'll be the rectangular pattern. Now the circular pattern, well, let's again create a new one to make this not too crazy. Another standard millimeter one. Now for the rectangular one, we have 2 choices, right? Remember that for the 2D one, right, we had to find a point around which we want to rotate this. Now we're in 3 dimensions, so we basically have to have a line to do this. We can create ourselves an axis, but we'll do that on Thursday. But what we can do, we can just draw ourselves a little circle somewhere. Let's go here, and let's do a circle. Doesn't have to be any specific size. And say okay. And then we also need to create something else to actually do here. So maybe we'll go do a polygon. Let's do something not too big. Oops. Polygon somewhere here. Something like that. Say done. Finish, and then we'll extrude this one just a little bit so we have a 3-dimensional object. Flat. All right, right there. Now we can take this and we can do the circular pattern, right? So we can choose our object, and now it wants to have a rotation axis, but this is in a different. This is not 3-dimensional. Let's get this one extruded as well. I forgot that. All right. Then we'll do our circular, choose this one, and then our axis goes right there, and you can see it already shows you, puts them all around here. All right, so you don't have to go all the way. You can say we only want half of it. Basically the same ideas like we had before. Oops. All right, so it would put them there. We can say we want to have the other way around, right? Flip that. All these kind of options that we have. We can also decide on how we want to have these placed. Right now, it's basically taking this one shape and moving it like this, but we can also have it move kind of without turning the other piece, right? There's a whole bunch of options that we can do, but in this case, I guess do 270 to spread them out a little bit. So we have them like that. Now, the fun thing is that we don't have to do this in just kind of here. We still did it more or less in 2 dimensions, right? We took a 3-dimensional piece, but we moved it there. So another way that we can rotate something, that we can create these patterns is choose this again. But now we'll choose, instead of the circle here, we'll just choose one of these axes. This one right here. And then you can see creates them all around there. Not sure what a good view will be, but from this in this direction, I guess. It's a good right? So you can see that it kind of went in into 3 dimensions. So we can do all kinds of stuff with these circular patterns. Then the next one is, or let's do the mirror first, because that's similar to what we had in 2D, right? We had the rectangular, circular, and mirror. Here we have another one. We'll get there in a second. So let's create another piece. Let's draw something. Sketch. Let's do a polygon right there, and we'll extrude it. And we never tried to do this with a polygon. We can do that with a polygon. Fun. So let's just do something more interesting. All right, and so now let's say we wanted to have this mirrored somewhere else. Again, we can use a plane here to do this, but we'll get to planes later on. So what we'll do is we'll create another object. Let's draw another object. Let's draw that a little farther away. Let's do a rectangle. Let's do a rectangle here. And let's extrude that. And now I can use my block here. Any of these surfaces I can use to mirror this other part. I'm going to turn it over there so we can see it. So if I do mirror, it'll ask me a feature. I'll grab this feature. And then it says the mirror plane. Now I can choose any of these planes. Of course, these side ones are not going to help very much. But if I use, for instance, this one, right, it's going to mirror it across my plane and put it right there. Now, the thing that I like in 3D that I don't do in 2D is that we can also mirror stuff along the main coordinate axes, right? If I wanted to mirror it on the XZ plane, I could do that. If I wanted to, oh, there it doesn't work, it's already in it, right? But I could mirror it like that, right? I don't have to create an extra plane for it. I could also mirror stuff that is not just straight up and down, right? So I can say if I wanted to do a mirror again, and now I choose this one to be mirrored, and then I choose my mirror plane to be, maybe that one's going to be difficult, but if I choose this one, right, then I can see that if it mirrors it, mirrored my block, and now it's kind of down there. All right, so that was the mirroring, and maybe we'll just stay on this drawing. Let's get to the back one here. Do a sketch there. And so let's put a bunch of points here. Oh, let's do our little thing first, maybe. Let's draw a little piece on there. And let's see it. Extrude that big 3. And say, okay, nothing special. Now let's say we want to have a whole bunch of these little pegs on here at some specific pattern, right? So I could go back in here, create a new sketch, and let's just put a whole bunch of points on there, right? So I can say here, 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 there, right? To just put some points. And then I can go to my sketch-driven one, choose my feature, and then it already puts them where all the points are that I just chose, right? Because there's really only this one sketch that will work. And I can say, okay, and it puts all the pegs right there. As of course, this was kind of random distribution, but if you had a whole set of points, then you would be able to do that. All right, so those are the patterns. Questions about the patterns? Well, they're very similar to the two-dimensional ones, so it should work fine. Then let's go and look at the last piece here, which is our revolve command, at least the last for today. And so let's do another one here, create, do another sketch, and let's just do whatever, some crazy shape like this right there. And then we also need to create another line. Let's do a straight line. Let's say finish. And now instead of doing extrude to go to the third dimension, we will do revolve. And you can see it already sees that there is a shape that it can revolve. And we have to select an axis. We only have one axis, and then it does basically this. Right? Again, we can tell it not to go the entire distance, right? We can do less than 360 degrees, maybe let's do half a circle, 180, right? And it creates this very fancy shape out of this. Now, most of you have already taken statics. So what does this remind you of? How good is your name memory? There was a theorem that was named after two guys. One that actually invented it, an old Greek, and another Dutch person who just basically copied it years later. I think in this case, only Gloriana and Montse are excused because they have not taken any yet.
Me neither.
Ah, oh, you haven't either. There you go. You're excused as well. The rest, ta. The theorem of Pappus and Goldinos. I would not expect you to remember this story.
I didn't remember that, definitely.
But you remember, so we did when we talked about the centroids of an object, right? We found that we could find the volume of a revolved object if we knew how far the centroid traveled, right? This is basically what this is, right? You take a shape and you revolve it once around an axis. And we can do this for very, very fancy axes as well. So the one thing that I wanted to point out here is an important distinction between these surfaces up here that are not flat surfaces and the cut points that we have right here. If we want to draw anything else, we can only do that on flat surfaces, right? So if I go onto here and say, do new sketch, then it's going to ask me where, right? You can't do it here. You can only do it on the flat surfaces. But once we're on the flat surfaces, we can do whatever we wanted to do before, right? We do a hole on here, right? We could say like, well, we want to extrude that hole, maybe do a cut, right? For some reason, and it will do all that for us, right? But we can't draw on these curved surfaces. Just doesn't allow it because there's no normal vector that it can create. So that was the revolve one. Now, a very fun thing that we can do with revolve that you will need a couple weeks is we can actually create spheres, right? All we have to do is do a half circle somewhere. Oops, that was not what I wanted. Double click there. Right, if I draw myself a half circle like this, and then I close it off so I can have a closed loop. And then I go into revolve, choose that, and around its own axis, then we can create a sphere. Right? So it doesn't matter how I look around here, it's always going to look the same because it's a perfect sphere. Now we can't do anything on this sphere because we can't do any drawings on them, but this is we'll learn how to interact with spheres as well. All right, this is what I was gonna talk about, but then of course we have some examples. But are there any questions yet? No, then let's do a new part. Well, let me move this around. No, there we go. And let's get our new parts going here too. So those we already did. Let's start with this guy right here. And that's all in millimeters, so we can create a new piece in millimeters. All right, so let's create a new part, still millimeters. And so now we want to draw this little whatever bracket here or something, right? And so we can see that we can't just go straight up or something, right? It has an angle here to it. So what we usually do is we start at the bottom or at the top or wherever, and we start working, right? So we can basically draw this bottom piece first, then we can draw another one on there, and then another one on there. So let's do that. Let's start a sketch. And so we can see this one here is 50 in one direction and 40 in the other direction, right? So we can say, do a rectangle. And so let's say we said 50 in one direction and 40 in the other direction. Remember, you can just hit that little thing and it will get us back. Looks good. Finish our sketch. And then we can extrude it up. It's supposed to be, we can't see that here, but it's supposed to be 10 wide. And I think it says somewhere that the material is 10 millimeters of 1020 steel. You will learn in material science what that means to be an SAE 1020. But for us, we just need to know that it's 10 millimeters, so we can extrude it up for 10 millimeters. All right, we have our base plate here. Now we can either start going upward, or we can kind of cut this hole into there. So maybe we'll cut the hole first. Do another sketch on top of this one. Oops. There we go. And now we know our kind of the rectangle that we're going to cut out of here is 15 millimeters, 10 on both sides. So it'll be 15 by 20. And snap to start right there. In this direction, we want it to be 15. And in that direction, to be 20. Now we still need to make sure that's in the right location. 10 from there. We want to be careful. We can do a quick check. Should be 10 down here too. Excellent. And so we can say finish. And we can do another cut. And there we go. We have our base shape done. So now we can draw upwards. Let's draw do another sketch. Put it where we need it. Now we need a rectangle that basically fits into here and is 10 millimeters wide, because everything is 10 millimeters. Snap it down to there, say 10. And we're good. Now we're on this level, but I want to go all the way up to there. So from this corner to that corner was 40, which means from this corner to that corner, which we're drawing, needs to be 40 as well. So upward 40. Zoom out. So now we're basically up to here. So we can just draw another one that goes outward in that direction. Let's do this, turn this around, do a sketch here. Do another rectangle. All the way down to there. Needs to be 40 is correct, but this direction 10. And then, so from this corner out would be 30, but we're already 10 there, so that would be 40. So overall it needs to be 30. And then we're almost done. All we left is kind of this cut here. We can do that by drawing another rectangle there. Now this rectangle is supposed to be 15 from this front edge. It's 40 in total, so 25 in one direction. 25 in that direction, and I'm guessing 10 on both sides, so also 20. And so sneak that in there. And finish. And now how far down is it supposed to go? It's supposed to be, so from there to the top was 40. Here's 15, so that's 25. Again, we cut, and not 30, but 25. And with that, looks like our little piece is done. All right, not that many clicks to do. Now, there would have been a way to do this easier. Who has a suggestion of how we could have maybe done this a little easier? Because in the end, we want to do as little work as humanly possible. Anybody have a suggestion how we could have gotten here with fewer steps in between?
You could have started with the top part and made like a sort of projection, since they are like equal measurements.
Not sure that I fully understand what you're saying, but I think what you're saying is right. We could have basically drawn this shape. Right? If we draw this shape and extrude it there, then we only need to do like one shape and two cuts instead of 1, 2, 3 shapes and 2 cuts. Right? So we could have done, nope, let's do a new one. Right, so we could have just started somewhere here. Well, we can say maybe we'll start at that point right there, where it says we'd have to go 10, 40 upward. 40. And then 40 minus 10 is 30. And then 10 upwards. And then 40 in this direction. And then let's see, so 40, so that'd be 40 down. And then 50 is another 40 in this direction. Same thing. And then 10 down. And 10 over. All right, so if we had done that, and then we can extrude this out. It was supposed to be the whole thing was 40. Right, then we'd have that same base shape, and then we could do our rectangle here and our rectangle there. Here goes cuts. Right, so that would have saved us some time. And again, the fewer of these little sketches that we have to do, the better. Number one, of course, the fewer we do, the like, less time that we spend. But also remember, every time you make a measurement, you introduce the chance of an error. Right? Every time I draw something, there's a risk that I'm typing in the number wrong, I'm reading the number wrong, or something like that. And so the fewer kind of steps that we make, the better. All right. Questions about this part? Relatively straightforward. Let's do another one that's pretty straightforward. We're in here. This is also millimeters. So let's do another millimeter one. And so now we have kind of this plate down here with 3 holes in it. And then a bracket that goes around and also has holes in it. So I would recommend probably start with the one at the bottom there. could start at the top. It really doesn't matter whatsoever. What I would recommend that some of you are doing, but some are not, is to kind of start your sketch at the origin. Right? It's just going to make it a little easier for you to see where stuff is. So we want to have a rectangle, and this rectangle is 100 times 40. 40 and 100. There we go. Now we could extrude this out and then punch holes in, but we can also just do the holes right now. So we can say we want to be, the holes are supposed to be 20. Let's make sure they're in the right position. So from here to there, it's supposed to be 20. Right, it says so right there. And they're supposed to be centered, and they should be centered because I kind of had it sitting on that dashed line, but just to be sure, it is. All right, now we can draw these other two, or remember, we can always use our rectangular function here. So we'll grab that circle. We have our line here ready to use for direction. It says here that the distance between the holes is 30. And of course, we want a total of 3 holes. So there we go. Then we can finish. Go right there. And we can extrude how thick. It says right there it's 10. And all right. Now we need to draw this part. I think what we'll do, we'll just draw a rectangle, another rectangle, and extrude it upward. Now we could flip this around and draw, basically use the plane down there to draw, but we can also just draw on this plane and then extrude up and down at the same time. So let's do that. Sketch. Want to have it on this side. Now this is supposed to be 40 wide and 10 thick. So we want to have this be 10 and that be 40. And then, oops, hard to see. What is that measurement? 30 away from that edge. So this edge and that edge are supposed to be 30. So we're good, and now we can extrude. And remember, we have the option to go both up and down at the same time, right? So we can use this asymmetric one. Down, it's hard to see, it doesn't really show, but of course that would have to be 10. So we're going 10 in distance D. And now we can't see. And if we want to go, I think we probably want to go up 40, right? It says to go up to 40 here, so we'll do up 40. And okay, and so now we have that back piece. Now we could first put the top on and then the hole. Sometimes, you know, when you build stuff over, it becomes hard to see. So I would recommend that we do that hole right away. So we'll need a new sketch. Quite so small. And so it needs a hole. What's the diameter of the hole? Oh, it says up here, 2 times 24. So we need a hole that's 24. 2, 4. And then where is it supposed to be? It's supposed to be the center is 20 from this edge and 20 from the bottom. So basically centered. Then that's close. And then this is also 20. Almost close. Finish. We could also just put a point there and then do the hole, but in this case, I think it's easier to do the drawing. All right, so we have our hole. Now all we need is this top part. So I would recommend that we just draw kind of the bottom outline, put the circle in, and then extrude everything but the circle upward. So that means we need to draw onto the surface. And new sketch, rectangle. And then it is supposed to come out 55. The 40 we already have. There we go. And then we need a circle, another circle of 24. Let's make sure that we don't bind it to anything there. 24. It is supposed to be 20 from the edge, which I think it already is, because it kind of grabbed the center there. So that's good, unless we can force it. And then 25 from the front. And say finish, and we can extrude. And 15. And with that, we are done. Looks more or less like we can see. Sometimes it's nice to kind of look at some details, right, to make sure that maybe we have stuff right. It seems that on the sketch here, we can just about see the other circle. We can just about see the circle here. You know, we can kind of see the bottom edges there, and so we can. I think so. That looks like we probably have this correct. Any questions about how we created this one? Now remember, Inventor does not care how you create this, right? Doesn't matter if we kind of created this shape and that shape and that shape, or did it in some different order. At the end, it is one big piece. It doesn't matter, right? We don't see any difference here, right? There's no line or something that was created by us as creating this part on top of it, right? All turns into one big solid piece. All right. Before we go on, I have one more example. Is the pace that I'm going through with these examples about right? Should I slow down a little bit? What do people think? Someone says full speed ahead.
Approved.
Approved. All right, let's do that. So here's the result. There you go. No. Let's do the last one. This one looks a little more complex, and it is a little more complex. And actually, I think that they made a mistake on there. We'll try that out a little bit later. All right, so we have this shape right here that we need to replicate. Now, whenever you start out, right, you should kind of look at this and say, like, well, what is, like, how do I start? Right? And of course, there's a little bit of experience in that, and that'll come with time. But what is kind of, I want to create as much of this shape as possible at the very beginning, right? So there's multiple ways I could start this, right? I could kind of create this surface and then draw down that surface and these ones on top or something, right? But again, that would be multiple steps. I think the easiest way is going to be to basically to create this shape right here, right? This kind of L with a spike on top or on the back, and then extrude it out. And then we can start cutting these pieces in and cutting everything else out. So I think that's what we're going to do. So let's start a sketch. We'll start with maybe that corner down there. So we get all the information. So we'll start with just a straight line going from that corner to there. So that'd be 8. Eight right there, and then we'd go up. So it says to go up, that edge will be 35, but we're going this, we need to know how thick this is. Probably going to be 8, but let's see. Yeah, you can see back here, it says 8. This one's a little tricky, right? So this 8 here belongs to this thickness, not to that one. So be a little careful there. So we know it's 8, so it's 8 everywhere. So it's said to go up 35, so we have to go up 27. Okay, that was not what I wanted. Let's get rid of this one. So we want 27. That puts us into that corner. Now it says from here to here is 40, and this edge was 8, so we'd have to go 32. 32. That puts us here. thickness we already know is 8. Then what else? Right, we can see back here, or almost can see it. Right, we can see that from the front corner, so from this edge right here to the straight lines right there is supposed to be 21. Or at least that is how I interpret this, right? This is one where it's a little bit unclear, right? They should have made this a little more clear where this 21 goes to, but otherwise it doesn't make sense. So let's say we'll do this one at go that one to 21. Then what is the height of these little guys? So 70 in total. We already did 35, so 70, we do another 35. It says the thickness is 8. We would not like about my 35. There we go. Thickness is 8. We go down 35. Right there. Did that when I checked on this yesterday too. I'm not sure what the glitch is on this one. It's interesting. For some reason didn't want to draw that line. And then of course we have to go all the way back to here. And then all the way down. All right, that way we have our overall shape done. Now we could extrude this and go from there, but before we do that, let's put in the fillets here. It says radius of 5. Where are my fillets? Radius of 5. There, 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 and there. All right. Now this looks about right. Well, actually, it doesn't look about right, but this is what the measurements say. And then it's supposed to be extruded for 100. The other direction. And there we go. All right, that's kind of our base shape is ready. So next, I would say we cut these kind of teeth into here, these saw teeth. And the way that I suggest we do that is we do a drawing on this surface. And what we can do is we could do a slot, because that looks very much like a slot. So we'll just choose our point right up here. Now this is the one that goes to the center. It says the center's all 14 in. It did the same thing yesterday. I'm not sure why it skipped the 90. Let's try this again. So we said 14, and it, for some reason, sets it back to 0. I'm not sure. And then, what does it say about the size of those? The distance between these is supposed to be 12. All right. Oops, need to go back into this window. Let's do that. 12. There we go. That looks about right. Now let's make sure that we have this correct. This should be 12. Okay, good. So in this case, we chose the right option. Now we won't, well, we could actually just leave it like that. It doesn't matter. I was gonna say we need to cut this and trim it, but in the end we don't need to because there's nothing else that we'd be cutting up there. So we can go again, we can do extrude. It even chooses only half of the one, so that's perfect. All right, doesn't matter how far back we do our extrusion because there's nothing there that we could break. And there we have our first tooth. All right, now we could go in and do this whatever 4 times. We could have just copied that 2D sketch, but we can also just use our linear part here, right? So it sees that this cut as a feature, so we can choose that feature. Then we need to choose the direction. That's our direction. That's positive direction. We know they're supposed to be 20 millimeters apart. And we need 1, 2, 3, 4. And oops, we forgot something, didn't we? Let's do this, right? So you can see already that we're not in the wrong space, right? We forgot to put a dimension there. Now let's see how good Inventor, how strong it goes. Let's go back into our sketch. So the good thing about Inventor is that you can change something later on and it will be able to track that through most of the time. Sometimes it can't. Now this distance is supposed to be 20. So let's move that out. And now it should move everything over, and it did. Right. So if you notice little errors that you made, you just go back, you make the change, and you see how far back Inventor can do stuff. Now, sometimes it gets too complex. Right. Sometimes Inventor basically gives up and says, yeah, that I can't. When you make this change, there's too many things afterwards. Like, there's maybe a surface that got intercepted by another surface, and so on and so on. And it can't do that. But for things like this, it can't, right? And obviously that makes it easy for us. We didn't have to go back and erase stuff and redo stuff. We could just kind of do stuff later. All right, with that, we're almost done. All we need is this cut right here. All right, this little one. And because it doesn't say anything about what these are, we just assume those are rounds as well. So we will just cut a rectangle and then do the round. So we do a new sketch. Something that I have yet to find is how Inventor decides where to zoom to when you go to a new sketch. Sometimes it's very, very strange. This is supposed to be 60 in this direction and 10 in the other direction. So let's find ourselves a point here. Let's go 10 there and 60 there. And then this time, let's not forget to position it. It's supposed to be 20 from there. So that's good. And then let's do our fillets, still on 5. So it's good here and there, and you know what? Let's do it just to practice the 3D fillet. Let's just cut it this way and then do it. Again, we cut. Okay. And then do the 3D fillet. There we go. Now 2, 5. That one. And we can see it right there. Can't see it, but it shows anyway. And it says okay. And with that, I think we are done. Right? That has basically all we have. And now we come to the part where I say, I think they made a mistake. Right? Because if you look at these two, they are definitely not the same. Right? The length here looks a lot longer than what we have here. And you can see that on my version, I can see the back. There's nowhere I'm close to seeing that back. So what I think what happened is that this 40 here is incorrect. This 40 should actually start at this line, not at that line. And if we go back, let's see if Inventor can go all the way back to our very first drawing. So let's open this up, right click on the sketch and do edit sketch. Now we have to pray that if we change one of these dimensions here, that it's not just gonna blow everything up, but let's see. So if we go back into the 32 here and say that this actually is not 32, but it's actually 40, did not change anything else, that was good. And we go back, then this looks a lot more than like what this drawing looks like, right? So I think this is they just got that wrong. Still looks a little strange because the cut here looks as if it were much closer to where the curve is. And we can't see details here in the back that I think we can see. So I don't know, maybe I'm misinterpreting something somewhere. But this is as close as I can get it. Are there questions about this one? No. Then let's do pull up what you need to do now. Obviously, it's already there, so it'd be 3 sketches. Again, these are all from the book, so you can find them there as well. But we have this relatively straightforward type of shape. It kind of looks like almost like a sofa or something. Now this is of course symmetric, so you can do half of it and mirror it if you want to. I'm not sure how much that buys you, or I think I would just do this straight up without mirroring. Here we have another one. So very, very important that this hole that's going through is based on this surface here, not on the kind of the sloped surfaces, right? So you want to make sure that you draw it on this one, and it goes all the way through, of course. Says there, through. Here you could draw half of it and then mirror it over. Again, I'm not sure if that's really gonna benefit you. I think I would just do a big solid block, and then I would cut this wedge out, like by doing a drawing on basically this front surface. Then I do a drawing on this surface with kind of this shape, do the cut through, and then the hole, and then you're done. So that would be that one. This one right here. There's nothing else going on in the back. There's nothing special happening there, so you don't have to worry. Very important here that this hole that's going through is perpendicular to the surface. Right, so it's not as straight down, it's kind of going straight into it. And you'll notice that at the end where it comes out, it kind of cuts both of these surfaces. So it's going to look a little strange when you look from the back. In this case, you're given the angle here, right? You're not given the width of the top here. You're only given the angle. So you'll have to dimension an angle. And then the last one is this one right here. You can see everything. The one thing is a little hard to see. There's a little bit of a nose sticking out in the back here. Right? So you have to put that in there as well. And with that, I think I will let you guys start drawing if you haven't already. Stop the recording.